Okay, now we will resume with our workbook. I give you a piece of homework, which is simply to find the area of a rhombus and a trapezium. What does a rhombus look like? So here I'm going to draw a rhombus. It has 4 equal sides, but it is not a square. So for example, like this being a rhombus, 4 equal sides. What are the properties of a rhombus? Well, it is similar to a parallelogram in that the opposite sides are parallel. In addition, opposite angles are the same, just like a parallelogram. Likewise over here. But when we talk about the area, we realize that if we were to cut this rhombus into 4 parts, you get 4 congruent triangles, 4 equal triangles. That means if I want the area, I just need to know one triangle's area. I multiply by 4. Okay, and here we have right angles. Okay, so this is another property of a rhombus. So you should be drawing this now. Any blank page. I drew it on page 115. Okay, a rhombus. The diagonals, they bisect each other. They cut each other into 2 equal parts at right angles. Now I'm going to further give you some information. If this distance, if I call it as A, from one end to the other end, it is A. Then I also tell you that the other diagonal, we call it B. A and B. These two they intersect each other at 90 degrees. Can you tell me the area of this shaded triangle? Do you think you can find out what is the area of this triangle? The yellow color triangle. Okay, first we need to know the formula for area of a triangle. So yellow area will be half times the base. What will you choose as the base? A or B? Which one looks like the base? A or B? A lah, right? A. Okay, so half times A, which is the base, times the perpendicular height. Where's the perpendicular height? Blue line or part of the green line? Or the entire green line? The entire green line is B. So what is the perpendicular height of this yellow triangle? Is it B? Or is it half of B? Half of B. We can see that, right? It is half of B. Okay. The perpendicular height is half of B. So this total area will be half times half, which is 1/4 AB. That's the yellow color triangle. Now what about the entire rhombus? If I want the entire area, just times 2 lah. So rhombus area will be 2 times of this yellow triangle, which is 1/4 AB. That is simplified to become half AB. This is the formula for finding the area of a rhombus. If you are given the diagonal length. Okay, diagonal means from one end to the other end, opposite end, and then the other 2 opposite ends. Okay, they will cut each other 90 degrees. This derivation, how we get this formula, no need to memorize. I'm showing you now so that it's easy for you to accept, rather than me telling you. Okay, for rhombus, the formula is rather than me telling you, okay, formula for rhombus, area of rhombus is just half AB. Then where is A, where is B? Well, this is our A, and this is our B. Yeah, that is how you can memorize it. Half times the diagonal, A times B. That's the answer. But difficult for you to accept lah. You know, wow, so many things to memorize. But if you know the derivation, it is easier for you to agree. Okay, half times the diagonals. That's all. Okay, then we just put it over here. Half AB. For the area of a rhombus, then you do a little sketch at the side. Okay, this is my rhombus. Okay, that's very poorly drawn. Okay, so this side A, this will be B, the diagonals. Then the next one will be a trapezium. Yesterday we covered half times the sum of parallel sides. Okay, sum of parallel sides times the perpendicular height. So these are the few that we need to know, including area of a parallelogram, base times the perpendicular height. So you see this term perpendicular height keeps on appearing, including for your area of a triangle. Area of triangle equals to half times base times perpendicular height. Important, obviously, to find out what does perpendicular height mean. So yesterday we covered for the triangles, perpendicular heights look like this. So for normal, the usual type of triangle, if this is the base, then this is our perpendicular height. From the end that was not used, you drop a perpendicular line down. Then we talked about the troublesome triangle that makes it difficult to find the perpendicular height. That particular triangle looks something like this, where you have one of the base, where you have one obtuse angle. This angle very big, more than 90 degrees. So if you choose this as the base, then where's the perpendicular height? You go to the other side that is not used, you drop a perpendicular line down to the base. Then you use a ruler. Okay, see the side square over here is 90 degrees. No matter how you join the other end to the base, you're not going to get 90 degrees. So what you have to do is to extend your base first. Extend it. Now, when you put your ruler or your set square on the point that was not used for the base, now you can drop a perpendicular line down. And this is your perpendicular height. This is the troublesome case. Okay? Now some of you are thinking, hey, why not we just make this as the base? Then this is the perpendicular height, isn't it? So obvious. Not all the time they give you this. They may not give you that base all the time. This could be an unknown, so you cannot use it. Instead, they give you this value. Let's say they give you 5 cm, and they give you this perpendicular height as 3 cm. Then you have no choice. And worst thing is, if they tell you that, oh, this is 4 cm, then you'll be wondering, should I use 3 cm or 4 cm? So you need to identify it by yourself. Perpendicular height. What about the perpendicular height of a parallelogram? So with a parallelogram that looks like this, choose a base. If you choose this as the base, then the perpendicular height, same thing. You go to a point that is not being used. You drop a perpendicular line down. So the set square, look, no matter how you join it, you're not going to get a 90 degrees unless you extend. Then you get a 90 degrees. This is now your perpendicular height. But some of you should be thinking, oh, why do I do so troublesome? How about I start from this point? It was also not used for the base, right? Drop a perpendicular line now. Oh, this is so much easier. Yeah, you're correct. These two are the same. Perpendicular height, they are the same. You can use either one of them. And finally, we have a trapezium. sum of the parallel sides times the perpendicular height. So now I'm going to sketch a trapezium. So this is our trapezium. Sum of the parallel sides, obviously the two longer sides in this particular case, times the perpendicular height. So perpendicular height, you start from one end, you drop a perpendicular line down. That is a perpendicular height. Whether you use this or you use this, they are all the same because they are parallel. Okay? And typically this will be quite obviously different. Maybe something like that. To track students who think that this is the perpendicular height. Are you going to be the one who think that this is the perpendicular height? I hope not. Now I'm warning you already. That is a trap. Okay, so now, write down, have we done ABC? Yes, we have. Okay, moving on to the next page. This is the plan of a room. Plan is just like a map. For those of you who are interested eventually in interior design, maybe you want to take out a course eventually in Polytechnic, interior design, go and design nice house, you need to work with floor plans. How much space you have. So find the perimeter of the room based on this. Part A, perimeter, if I were to highlight it, perimeter is just the outline. Very simple outline. So perimeter will be 5 plus 12 plus 20 plus 15 plus 16. So 17, 68, 68 meters. That's quite big. That's really big. Okay, next, to find the area of the room. So part B, area. Okay, how will you do this? I give you some time to think. You divided it this way. Most people are. Okay, can. So the area for the trapezium will be half times the sum of the parallel sides, which is 12 plus 15. Because this is 15 and this is now 4. That is our perpendicular height. Plus 4. Then you add 15 plus 16. 15 times 16. So you get 2 times 30, 27, 54 plus 15 times 16, 294. Okay? Most students, you are doing it this way. Now, is there anybody who did a rectangle minus triangle? Rectangle minus triangle, okay. So rectangle minus triangle, what does it look like? This is the rectangle. So area will be 15 times 20, then minus half times the base. This is 3, this is 4. 3 and 4. So this is 300 minus 6, 294 square meters. Same answer. Okay, we are just taking away this triangle. There is one last way to do it that I can think of. That is dividing it this way. So this will be 12 times 20 on this side. Then this will be half times the sum of the parallel sides, which is 16, plus 20, then times the perpendicular height, which is 3. Then add them up. Same answer. So 3 ways to do it. Okay, next one at the bottom. Oh, by the way, I was telling some of your classmates that this type of question, 3 or 4 marks, or maybe more. You know, perimeter, 1 mark, 2 marks. Then the area, because there are more steps, maybe 2 marks, 3 marks. So easily, 5 marks over here. 5 marks out of 50 marks for one paper. That's a lot. So make sure you can do them. Okay, next one, rectangular cut, 2 triangular holes cut. Calculate the shaded area. Okay, please try this now. The area of this cut will be the area of the rectangle first. It is literally a piece of rectangular paper. You cut away two triangles. So you find the area of the rectangle, you take away the area of two triangles, then that's the answer. So area of the rectangle will be 4 times 6. Then minus 2 of the triangles. Now your presentation may be different. Maybe you're finding area of triangle first, then you subtract, fine. I'll write down everything in one line. 2 times of the area of a triangle. So area of one triangle is half times the base times the height. So in one step, it can be done also. I'll just put some notes. Rectangle. This is one triangle. So we have 24 minus 4, which is 20 square centimeters. Okay, who needs more time on this? Who needs more time? No, then move on. Okay, now, sectors. So we are still dealing with area and perimeter. Recap. For a full circle, what is the area equal to? And what is the perimeter? Otherwise known as perimeter / circumference. Okay, so these two must know, okay? Who haven't memorized this yet? Who has not memorized? If you have not memorized, I will not call you. Who hasn't memorized? So the rest memorized already. Okay, Reese, what is the area of a circle? Then you never raise your hand. Okay, who can help Reese? Area of a circle. Audrey? Pi r squared. Write this down in your notes. Pi r squared. What about the perimeter? 2 pi r? Yes. How to remember? How should we remember this? No. Okay, so you think about the units. Units for area. What does the unit for area look like? Examples. Examples or units of area. cm square. Square meters. mm with a square. km with a square. What do you notice for the units for area? Yeah, all that have a square, right? So looking at the area of a circle versus the circumference of a circle, if you ever get mixed up, how to remember? The one that has a square is the one for the area. The one that has a square is the one for the area. So for one full circle, that is 360 degrees. From the center, 360 degrees. If I do not want 360 degrees, let's say I only want a part of 360 degrees. For example, if I only want 20 degrees, and I want this area. So this shaded area will be, either you write it as 20 out of 360 times the area pi r square, or you can write area of, 360 degrees represent pi r square. Because this is for one full circle, then 20 degrees will now represent, and you do your same working, divide. So pi r square divided by 360, and then you multiply. So you multiply by 20, and you get the same answer. That is for area. You do the same for circumference also. How many degrees? 360 degrees represent 2 pi r. Then however much degree you want, then you have to figure it out. Okay, so back to our question. 1a. Find the area of this sector. If you are very free, you can complete the circle. Okay, to get a better idea of what is happening. So this is the entire circle. The radius is 12. The angle AOB is 30. Calculate this area. So to find this area, I need the area of the entire circle. Area of entire circle has a formula, which is found by pi r squared. Okay? Now, we only need 30 degrees out of the whole 360 degrees. So I'll show you the two presentations. The first presentation, you can say area will be 30 out of 360 times pi r, radius is 12 squared. So the answer, use your calculator. Okay. $37.699. 37.7 square meters or square centimeters. So this is one way of doing it. The other way is if you use the units to represent. Full circle, 360 degrees. Represent pi r squared. So what we are saying is that the whole area is pi r squared. Totally makes sense. But now I only want 20 degrees. Represents, divide. So pi r squared over 360. Next step is to multiply times 20. And you get the same 37.699. Round it off to become 37.7 square centimeters. Okay, so two ways of doing part A. The fastest way is the first method. The other way, the second method, the structure, like I've always mentioned, can be used many times in many situations. Not just for your area over here. Okay, so this one highlighted in blue, very useful for many other situations. Proportion, ratio, all of them you can use this. Okay, can I erase this now? Put this more time. Now next, perimeter of the sector. First, you need to identify where the perimeter is. Can all of you trace the perimeter now? I think I wrote 20, but it's supposed to be 30 over here. My answer was correct?
Yeah.
But did I write 20 or 30 degrees? I wrote 30, huh? Sure?
Yeah.
Okay. If I wrote 30, then it's correct. Look out. Those that say it's wrong, huh? Perimeter is the outline. Perimeter of what? Perimeter of the sector. Where is the outline of the sector? The outline of the sector is here. There's a curve. There is a radius. And there is another radius. This is the outline. Do you see that? Okay, so like I said, very wasted. I think most of you can find this, which is what the N-level syllabus wants to test you. Then the other word, perimeter, is a primary school concept. It is the outline. That is not exactly what they want to test you, but very wasted if you don't know the meaning. So just plus 12 to that curve over there. Therefore, part B, perimeter. Let's talk about the curve first. The curve will be 30 degrees out of 360 times 2 pi r plus the straight line, which is the radius, plus another radius. There are three parts to it. This is for the arc length. Then this is radius. This is another radius. Yeah, I say you were correct, right? I say you were correct, what? I say you wrong. Yeah, I say you correct. Can. Okay, now plus 12 plus 12. Okay, your answer should be 30.283. Wrong, meh? Right. Right. 30.3 cm. Alright, so this arc length, I use the first method. If you are wanting to use the second method, same structure. It looks like this. 360 degrees represent 2 pi r. That is for the circumference now. Then we only want 30 degrees. Represent, divide, times 2 pi 12. 360 times 30. Get the same answer. So this will be 6.2831. Then you still need to add total 12 plus 12 plus 6.283. You get okay, so this is the second method. Alright, now for question 2, minor. So the area will be 160. 160, 360 pi r squared. Minor. You all get 50.265? Is it 50.265? Okay. So round it off, you got 50.3 square centimeters. So the length of the major arc. So this must be the major arc. Did I include the radius for part B? Should we include the radius for part B? Yes. Who say yes? What's yours? One must include the radius. You did. I anyhow say that. Then what you anyhow say? Radius. For part B, they only want the length of the major arc. They didn't say perimeter. So just the curve is enough. What about the radius? The length of the major arc, just the curve. Don't want the radius this time, because not perimeter. So that will be, oh, we need this angle. What's the angle? How to get 200? Okay, correct. 360 minus 160 divided by 360 times 2 pi r. Huh? Yeah, the r here, 6. No, as in r. I mean, you don't need to add the 2 radius. Don't need to add, but we still need to use it. Okay, so we get 200, 360 times 12 pi. 20.943. 20.9 cm. Okay, who needs more time? No need. The next question. These are the arcs AB and CD of 2 circles, center O. They share the same center, radius 6 and 11. Okay, for this question, I want you to put a star because there is a misconception. Put a star for this. Okay, now the important thing I want you to do is to trace out this big sector. Just trace it out. Trace and write radius equals 11 cm. Radius is 11 cm, not 5 cm. Okay? Do you know why I'm saying this? Because you may have the misconception that this 5 cm, it belongs to the big one. They may think that, to find this shaded part, to find the area of the shaded part, you use the radius as 5. But no, that's not correct. The radius is 11. Okay, this 5 over here is not a radius. The 5 is not a radius. This 5 cm is not a radius. This 6 cm is a radius. Because we start from the center of the circle. This is a sector. So this is 6 cm, that is a radius. And the 11 cm over here, from here to here, this is another big radius. Okay, for the big sector. But the 5 cm here is not a radius. Because if you fix one point, you put 5 cm, you draw radius, that isn't part of the diagram. You see that? 5 cm is not a radius, huh? Okay, let's continue. We've got 60 degrees here. Find the perimeter of the shaded region. Perimeter of the shaded region, I'm going to highlight it with yellow. Perimeter of the shaded region. Do you all agree? This is the perimeter. Because the outline. Now we can start for part A. You can do it in one line, or you can break it into one arc plus another arc. Then plus the two 5 cm. Okay, let's start with the small arc, AB. We do it step by step. AB. How do we find the length of AB? Looks rather complicated, but it's not. Just cover up everything else. I just want the arc AB, this curve. And we've done it so many times. It is the same as 60 out of 360 times 2 pi r. But what is the value for r? 6, yes. Okay, so we get times 12 pi. It's 6.2831 cm. Don't round off yet. Don't round off. This is not the final answer. So that's AB only. Then I want to find CD. Can you fill in the blanks for CD by yourself? C out of 360 times 2 pi 11. Yep, 11.519. Then the whole perimeter, 6.2831, 11.519, plus another 5, plus another 5. They came from these two straight lines. Okay, the perimeter is made of a curve, plus another curve, plus two straight lines. Total 27.802. So that is the perimeter. Perimeter done. What about the area? How shall we find the area? So the area of the shaded region is just the big sector area minus the small sector area. Area will be 60 out of 360 times pi r. The radius is 11. Thank you. This is the big sector area minus the small sector area. Big sector. Small sector. Alright. Okay, we'll finish up with the last question for today. One last question, question 4. So here we have a figure by joining two squares. Each side 10 cm and a sector area 30 degrees. Angle 30 degrees. Find the perimeter. Outline the perimeter. So there are a few parts to it. Part A, perimeter. We have the curve first. So the curve 30 over 360 times 2 pi radius is 10. This is for the arc. Then you plus so many 10. 1, 2, 3, 4, 5, 6. 6 tens. This portion is the arc length. Then this is for the 6 sides of square. $65.235. 236, okay. So perimeter, straightforward. Now the area. Same approach, find the area of the sector. So 30 over 360 times pi r square plus the area of two squares. 2 times of 10 times 10.